Yes.
White screen. You can see?
Yes.
Okay. So the last class we were discussing the property of integers. Integers. I'll make the font bigger. Is the writing visible? Is the writing clear?
Yes.
What I'm writing you can read?
Integers.
If you can't read, I'll make the font bigger. I'll make it bigger in size. Integers are closed when added, subtracted, multiplied, but not when divided. Not when divided. Similarly, okay, integers are closed when added, not when divided. Similarly, integers are commutative when what? Integers are commutative when
Add.
add and multiply. Added and multiplied.
Multiply.
Not when subtracted. Not when subtracted or divided. Are commutative. Put comma. And then similarly associated. Integers are associative rather. Integers are associative when same thing added, multiplied, multiplied, not multiples. When added, multiplied, not when subtracted or divided. Right? There's a thing.
Okay.
No, you already know this. You know this or you don't know this one? This one we have already done.
I know.
You know this. So the type of questions, one is that show 3 plus 5 equal to 5 plus 3, but we will show you the type of questions. In actual question it won't be 3 plus 5, and name the property. So what is it? You will have to write like this. Left side 3 plus 5 equal to 8, and right side equal to 5 plus 3 equal to 8. So right side equal to left side. So left side equal to right side. This is the way you will do it. And name the property. What is the property? 3 plus 5 equal to 5 plus 3. What is the property?
Commutative.
This is commutative. Commutative. This is commutative property. So this is the way we are given the questions. Similarly, it might be show that 3 minus 5 is not equal to 5 minus 3. Name the property. So first is that again left side 3 minus 5 equal to how much? 3 minus 5?
3 minus 5. 5. 6, 7,
3 minus 5.
8.
3 minus 5, not plus 5. 3 minus 5. Plus 3 minus 5. Plus 3 minus 5. Oh, sorry, minus 5. Plus 3 minus 5, how much?
3 minus 5.
What is the difference? They are opposite signs. One is plus, one is minus. Opposite signs.
2.
2, what 2? Which is greater? Minus is greater or plus is greater?
Minus.
Minus 2. So it is
Minus.
minus 2. And right side, 5 minus 3 will be equal to, that is plus 5 minus 3 will be equal to how much? This time?
2.
2. 2 or plus 2. Either you can
2.
write 2 or so left side and right side are not equal. Left side is you will put the sign actually. Here, okay, I'll insert the sign. You will be putting the sign. Sign of not equal to. Yeah, this one. Not equal to right side. And property you will write not commutative. Integers not commutative for subtraction. Integers not commutative in case of subtraction. Actually, it is or under the operation of subtraction. The correct term is under the operation of subtraction. We write in short. Actually, the correct term should be not in case of subtraction. The correct term should be under the operation of subtraction. But in short, you write for subtraction, in case of subtraction, whatever, or when subtracted. As you can write for subtraction also. This also you can write for subtraction, or you write when subtracted. When subtracted. There is a short form. The full form mathematically precise is under the operation of subtraction. So there is the similarly for associative also they will give. Similarly for integers, that closure property. Closure property. Show that for numbers 3, 6 the integers are not say commutative. Are not commutative. Somebody will write 3 divided by 6. 3 divided by 6, this division sign. 3 divided by 6 is 1 by 2. And it is also not closed. Not closed and not closed and not commutative. Both. So 3 by 6 is 1 by 2. But if you write first 6, then you write division. First 6, then division, then 3, then it will be equal to 2. Okay?
Okay.
6 divided by 3 equal to 2 and 3 divided by 6 equal to half. So what happens? First of all, left side is not equal to right side. First this one. Here there is no left side given, so let it be. Don't write left side. So what you write? This is not equal. First is not commutative. 6 divided by 3 is not equal to, is not equal to 6, 3 divided by 6. That is the first part. So that means it is not commutative. Not commutative. Not closed and not commutative for division, I forgot. And under Under operation of division. Sorry, I forgot the full term. Under operation of division, sir. Not commutative and not for under. So 6 divided by 3 is not equal to this, not commutative, and 3 divided by 6, this part, 3 divided by 6 is not an integer, is a fraction, is not an integer. It is a fraction. 3 divided by 6 equal to 1 by 2, right? 3 divided by 6 equal to 1 by 2 is not a fraction. That means not closed. Not closed. The answer is not an integer, not closed. So neither commutative nor closed. Right? Got it?
Okay. Got it.
And sometimes you will have to show that two integers are not close. Then you choose your integers. Here I gave you 3 and 6. Sometimes you take your own numbers. Any two numbers, simple numbers. 5, 10, 4, 8, 9, 3. Take any simple numbers. If they are not giving the numbers, then you take simple numbers. But in most cases, what will happen? You will have to say about compare 3 plus 5 plus 3 and 3 plus 5 plus 3. Compare this one and comment on integer property. So, again same thing. First part, 3 plus 5 by 3. Either you can write left side or you can copy this one. Or you can write this one will be equal to how much? 3 plus
3 plus 8.
8. That will be equal to 11.
11.
And the second one, this one,
8.
8 plus 3, that will be equal to?
Equal to 11.
So what you are finding, they are equal. They are equal. So left side equal to right side. So what is the property? Associative. So integers are associative under or when multiplied. Simple, you write when multiplied. When added, sorry, not multiplied. When added, or the correct term is under the operation of addition. Under the operation of addition. That also you can write. Under the operation of addition. In short, we write when added or for addition, or in case of addition, the correct term is under the operation of addition. So similarly, that can be for division as well. Right?
Okay.
In case of rational numbers, the same thing will come with division. Then it won't be integers. They will say rational numbers, then they will give you fractions. And integers, they will give you like. And they can also give you this one, negative. Like 5 plus minus 3. So this is one thing. And plus 2. This one, and the same thing will be there grouped in a different manner for associative. There's the same thing, only different grouping will be there. So bracket will not come here, bracket will come for the last two, right? Bracket will come for the last two. This one will mean bracket. Yeah. This will mean bracket. Here also you can put that bracket if you want. This, instead of this bracket, you can put this bracket. Yeah. So again the same thing, the thing will be same. First take one by one. The first one. The first one.
5.
First do the bracket part. That means this part. This part you'll do. First do the bracket part means the red one. Yeah. You can see the red color. Do the red color first because that is in bracket. So red color how much?
+2.
Plus 2. Then plus
Plus my
plus minus
minus
2.
2.
That will be equal to plus 2 and minus 2.
+2 minus 2.
Plus 2 and minus 2 0.
4.
Huh? Plus 2 and minus 2 0. Equal and
Oh,
opposite. Positive 2 and negative 2. Equal and opposite. Then equal and opposite will be minus 2 because this plus and the plus outside the bracket and minus inside the bracket. Plus and minus will be minus. So 2 minus 2. Right? It will be 2 minus 2.
oh.
So, and the next part will be this one. I can also give you this part. Yeah. Now this one will be in red color. Means this one will be in bracket. That we'll do first. So first copy that part because this part you are not doing. So copy this one. Plus. Now
5.
this part. Which 5? Minus 3 and minus 2. Which 5? Plus 5
Minus.
or minus 5. Say the always minus 5 plus 5. So it will be minus 5. So plus 5 and minus 5 again. Equal and opposite. Positive and negative. Plus 5 and minus 5. What it will give you?
Negative. 0.
0, not negative. Yeah. Positive 5 and negative 5 cancel each other, giving you 0. So, left side equal to right side. The property will be 2 numbers means commutative and 3 or 4 numbers that means your grouping that is associative. If there are only 2 numbers like 5 plus 3, 5 minus 3, 2 numbers, it will be commutative. If there are 3 or 4 numbers, it will be associative. So, associative under addition. Integers are associative under addition. Under the operation of addition. Actually, the correct term should be under the operation of addition. Or if you want short, you can write for addition or you can write when added. Integers are associative when added. That also you can write. So under the operation of addition, integers are associative. So it can also be plus and minus sign. And for the same rule, you will get the rational numbers. Then it will be fractions. Same rule. Closure property, associative, commutative. The same property will be for rational numbers. Then it will be fractions. 2 by 3, 1 by 2. So there's the... so integers property and rational property will be same thing. Integers property and rational numbers property. Rational numbers property. Both the same thing. The same thing you will get. Commutative, closed property, commutative. But in rational numbers property, you will get fractions. The same thing you will get. Like 3 by 4 plus 1 by 2 is equal to 1 by 2 plus 3 by 4. Same thing you will get. If they are equal, commutative. And if I put minus, they will not be equal, then not commutative for subtraction. If you multiply, the same thing you will get. Ultimately, you will get the same thing. But the property is same, only you will get fractions.